On Earth, everything gets pulled down because of gravity. If there was no air, all objects will fall on the ground with the same speed and time no matter what the mass of the object is. During free fall, the only force that acts upon an object is gravity. When this happens, all objects will be accelerating downwards 9.8 meters per second, which is also the acceleration due to gravity.
Gravity pulls sky divers toward the Earth. But as we fall, tiny air molecules bump into us. Each tiny bump causes a little bit of force against our bodies. The hit from one air molecule may not seem like a lot, but when you add all those tiny forces up, you get a big force called drag, which pushes up, opposite to gravity.
As an object falls through air, it usually encounters some degree of air resistance. The amount of air resistance that is encountered is dependent on the speed of the object and the cross-sectional area. Increasing speeds and cross-sectional areas both result in an increased amount of air resistance. A falling object will continue to accelerate to higher speeds until it encounters the amount of air resistance that is equal to their weight. When this happens, terminal velocity is reached. Terminal velocity is when an object is falling under the influence of gravity until it reaches a maximum velocity where the air resistance force equals the velocity. The way parachutes work is that it dramatically lowers your terminal velocity by increasing your air resistance as you fall. It does that by opening up behind you, creating a large surface area of material with a huge amount of drag. Parachutes are designed to reduce your terminal velocity by about 90%, so you hit the ground at a low speed that is about 5.6 meters per second. We did an experiment where we compared the average time that it took for a flower without a parachute, a flower with the 15 by 15 centimeter parachute, and a flower with the 20 by 20 centimeter parachute to land. Air resistance does exist, but it was not calculated in this experiment, and the mass of the flower was 0.02 kilograms. The time that it took for the flower without a parachute to drop was 0.77 seconds. The time that it took for the flower with the 15 by 15 centimeter parachute was 1.78 seconds. The time it took for the flower with the 20 by 20 centimeter parachute was 2.14 seconds. The time for the flower with the parachute was greater than the one without one because the parachute was reducing the terminal velocity of the object, so the landing time was greater. The time for the 20 by 20 centimeter parachute was greater than the one that was 15 by 15 centimeters. This is because the 20 by 20 centimeter parachute had a greater surface area. The more surface area, the more drag that will be created.